For the news today, I wanted to follow up on one story. That was the Itential story that I mentioned last week. I got a briefing from Chris Wade, co-founder and CTO at Itential. I got some clarification from what the announcement was that I mentioned last week in passing. I didn't have anything wrong as such. I just didn't get all the nuances. And here's one important bit of information that Chris emphasized to me: data transformations. Okay. What that's really all about is it gives you, if you're in the automation world, the ability to use Itential as the middleman to mix and match different data sources and then map them to wherever you need them to go. So here's a graphic that Chris showed me something similar to this anyway. But the idea is you've got incoming data, incoming schemas. You can then map those schemas and transform that data however you might need it, and then send that data out of the Itential system in whatever form you're looking at. So, say you need to populate multiple different databases, data points, data fields, as this data is flowing out. Well, you can transform that data however you need so that that data shows up in that remote database, that remote system, however you need it to be. So if it comes in as a string on the one side, let's say, but it needs to be numeric on the other, you can transform the data to do that. Well, why do we care about this? Well, you care about this if you're dealing with multiple input and multiple output data sources and data destinations, because when the providers of those data sources and destinations change things up, well, you don't have to change your code. You can let Itential handle that in the middle. All you need to do if something changes, redefine your transformation so that your code can stay the same. Think of Itential as kind of middleware here that is sort of proxying the data for you so that it becomes whatever you need it to become, again, without you having a breaking change introduced by one of the vendors that is integrated into your automation system. They change things doesn't mean it breaks you if you've got this middleman, Itential, handling it for you. That's the big idea here. And they've got a bunch of transformations that are built in. They've got a whole set of them here. I think there's a link to, pre-built transformations. They have a pre-built collection that are there on their developer site that let you do all sorts of different things. And then the screenshot I showed you here is from their JST schema transformation tool. So that tool allows you to design whatever you need if what's pre-built doesn't get the job done for you. That's all the network automation news I've got for this week. So let's move on to this week's educational segment. We're going to talk about structured data. All right, programmers, structured data is our topic today. This is going to be a very short little presentation here so that you understand what I mean when I'm talking about structured data, as it's one of those topics that means lots of things to lots of people, all depending on the context in the information technology world and then what their discipline is. Are they talking about programming? Are they talking about storage? Are they talking about databases? Structured data has different meanings depending on what discipline you're getting at. So let's talk about it from our programming perspective, the one that we care about as we're focused on network automation. When I'm talking about structured data, it's about context. Do I have context around this data so that I know what it is, that I've got some clue about it? Let's do a comparison here. Unstructured versus structured data, and I think you're going to get what I'm talking about. Unstructured data would be kind of a blob. I ask the CLI something, let's say, on a network device, and it spits back a bunch of output to me. And that output isn't formatted in any useful way. Well, it's formatted for the screen, so I can kind of, with my eye, look at it, but it's really a blob from a programmatic perspective. A computer program, a script, doesn't look at that data that we look at with our eye and see individual elements in it. It just sees the string, the whole thing that came back to it. So it's kind of a blob. That means, from a programmatic perspective, the individual data bits in that blob are unreferenceable. And if they're unreferenceable, I can't do anything with them. And that means it's not really that useful for computation. In other words, in a script, if I want to do something with that information, it's not completely useless, right? Because I've at least got the blob, there's something there. But without being able to get at the individual elements in any easy way, that unstructured data isn't really helpful. So then, structured data. What about structured data? Well, it would be delimited. So here's a simple example of structured data that has been delimited. A CSV, a comma-separated values file. You've got a header row that tells you what each value represents, and then you've got data rows, and each data element is separated by a comma. You can import that CSV into a spreadsheet, and then every cell is populated with a chunk of data, and that data is referenceable. Now in my spreadsheet, I can go cell A1, let's say, and get the bit of data that is stored in that cell. Ah, that's interesting. I can do things with that. And again, sticking with our spreadsheet example, I can do math against that value that's in that cell, or do a lookup table. And there's lots of interesting things I can do because I can reference that data. That means my structured data is therefore computationally useful. So if instead of getting a blob back, I can somehow break that blob of data I get back from a network device CLI up and reference each element that's interesting to me, oh, I can do all kinds of cool stuff. So let's look at a couple of examples. Here is an unstructured data example. What are we looking at here? This is actually a screen cap of me going to a command line traditionally via SSH like you would, typing a command in and then getting that data back that's been formatted for the screen so I can look at it, and as a human, that means something to me. There's some columns and some spaces there with some headers and so on. It's actually just one big string. It's just one chunk of data that from a programming perspective, when I get that blob back, as I did in episode 1 of season 2 last week, can't really do a whole lot with that. I can print it to the screen, I guess, which doesn't really do much for me. But what's interesting is if I could do things like pull out individual MAC addresses, or maybe give a report that says, here's all the MAC addresses I know that live on interface GI0/0. That is interesting. That is maybe useful. But because the data is not structured in this format, there's nothing I could do with it. So what would structured data look like? Here's the same output that has been run through a Python script and parsed so that each individual data element has been pulled out and is now referenceable. So there's something I can do. So this is a bit cryptic if you're not used to looking at this. So let me turn on the pen here and highlight a few things for you. What you're looking at is a Python list. Each list element contains a small dictionary. So a list is delimited by these square brackets. And then within that list, I've got these dictionaries. So here is list element 1. It's this dictionary. And a dictionary, you might remember from the last episode, that is a set of key value pairs. So we've got a key of destination underscore address and a value of that MAC address ending in 4241, etc. Okay, now this is referenceable data. This is something I can, in my Python script, go and tell the Python script, hey, for this list item and this dictionary item in this list item, I want to know the value. And I can do lots of things with that. I can generate lists, I can do searches, I can do sorts, I can save all this information to a database in a very organized fashion. The structure gives me that capability, and that's what's crucial here for us, is this structured data. There's all kinds of different structured data that exists in the information technology world. We are going to focus in our next example on taking the Python script that we looked at in episode 1 and not really changing it much except to parse the response that we get back from the command line into structured data. And I'm going to show you exactly how we do that with some new libraries. For this demo, we're looking at structured data. We're going to take the script that we ran in episode 1 and add to it so that the result we get, rather than being kind of a blob, just whatever the CLI would have spit back at us, we're going to take that blob and turn it into structured data. Our network topology is very simple. I've just got the one switch, the same as I had up last week. Nothing very interesting there. 172.22.46.1 as a management IP that I can use for that. So let's take a look at our Python script. Here's the script. It's going to seem a little busier than the version of the script last week because it is. I've added a number of things, comments being one of them. I am very big on documentation and scripts being self-documenting. That is, Write comments that explain to you what the script does. Notice I didn't say explain to someone else because that's nice and that's important, but you're the one in many cases that you're doing the documentation for, so that when you pull this thing up in a month or 6 months, you remember what in the world it actually does. When you're writing scripts, especially if you find specific commands that do whatever magic for you, you won't remember very likely what that command was or how it worked exactly. And so when you write some comments in your script, you're doing your future self a favor. Love your future self. Document your code. At the very beginning here, I'm just mostly for purposes of beating the whole commenting thing to death, really going for it. So line 1, import libraries for extra functionality. And then, hey, what do you know? At the ends of line 2 through 4, you'll notice that you can add comments to the end of a line as well. What am I doing here? I'm importing a library called pprint. Well, this is core to Python. It is pretty printing, and it takes something like a structured data object, let's say, and prints it in a pretty way, so it's easier for you to digest rather than seeing everything character by character. It'll break it up by lines and use indentation for you. We're going to use that later in the script. Import netmiko, same as we did last week. And here's a new one from compared to last week, from ntc-templates.parse import parse underscore output. What I'm doing here is, rather than import the entirety of the ntc-templates.parse library, I'm importing one specific function, parse underscore output, which means I don't have to describe the entire object and method from that library that I'm going to be using in my commands. The only part that I really need is parse underscore output, so that's the part that I imported. Oh, and what is the ntc underscore templates? Well, ntc, network to code. If you're not familiar with those folks, they are a company that specializes in network automation, and they've made a number of contributions to the network automation community, this being one of them, ntc underscore templates. This library is going to allow us to take command that is sent to us from some show command or some CLI operation that we do, and then via this series of templates, parse the output into structured data. Pretty crucial for what we're doing. But I'm going to emphasize something here. It's amazing what the community gives you for free. It doesn't cost you anything to have this. So that's what line 3 is all about. Line 6 through 7, I'm documenting what that paragraph is below. It's the same as we talked about last week. And hey, I added a URL. So if I wanted to click through, because I was trying to remember the rest of what that little dictionary is that is required by netmiko so that I can log into a device, I could go find that easily. Because in fact, there are more than the 4 parameters that of device underscore type, host, username, and password. There's more that's there that you might need in certain circumstances. The URL clicks through and it'll show you what the rest of those are. Nice thing to embed in your comments. Now we get to some of the more interesting bits. Lines 15 and 16, it's a comment with a command. We defined the network device in the dictionary above as network underscore device. So now we're going to open a socket or a connection to it. So I've got a variable I've created, socket. What does it equal? It equals netmiko.connectHandler. This is what's going to open up that socket for me. Again, same as what we did last week, only I've changed the variable names to make it a little more logical, a little bit more modular, reusable, generic, if you will, rather than being so specific. I named some very specific variables last week that would mean it would read rather clumsily depending on what I was trying to do. So I've updated these names purposefully to make this code more reusable. Reusing code's kind of a big deal. Lines 18, 19, and 20. Okay, what are we doing here? Well, we're going to define the command we're sending to the CLI as a variable. In last week's episode, I actually sent it as a literal. It was in single quotes. The show MAC address table command was done as a literal. Now I'm using a variable, the underscore CLI underscore command. Well, why? I'm using the underscore CLI underscore command in more than one place. And we're going to see where in just a bit here. Lines 22 and 23, I'm going to send my command to the network device over the socket, and then I'm going to save the unstructured result. Again, same as we did last week, just updated variable names so that it reads better. CLI underscore output underscore blob equals socket dot send command parentheses the underscore CLI underscore command. Yeah, did you like the way that reads? That reads pretty good, huh? So you know that you're going to get some CLI output in an unstructured format, a blob. And how are you going to get it? Well, you're going to do it by sending a command to that open socket that we made. And what are we going to send? Well, we're going to send whatever is contained in the_CLI_command, which we had defined earlier as that show MAC address-table. You could put any command in there now if you just redefine what in line 20 what the_CLI_command variable is and send any command you want. Lines 26 through 27, I'm going to use the ntc-templates library and parse that blob, that unstructured result, into a structured result. And I'm going to save it as CLI_output_structured. So as opposed to _blob, I've got a contrasting variable I've created called _structured. Well, how am I going to do that? Well, I'm using in line 28 the parse_output directive. Well, where did I get that from? Well, let me scroll back to the top for you. Look at line 4. That's where I got parse_output from. I imported it as a function I can use from ntc-templates.parse. A point here, now I didn't mention it earlier, but ntc-templates, I had to install that. I used pip3, a package installer for Python, and I installed ntc-templates and added that to my Python library. Just like last week, I did the same thing with netmiko. I did pip3 install netmiko. Parse_output needs to know some things. In other words, how does it know how to interpret the blob of data that we're going to give it? Well, it's through the definition here that's in parentheses. So I've got a platform equals Cisco_iOS. So it knows, oh, okay, so I need to interpret this data as if it's coming from a Cisco iOS device, because different devices are going to give you different kinds of output. This is Cisco iOS device, so it needs to know that. It needs to know what the command was that would have sent back this blob. So now we've got some context here. The command was, oh, that variable I defined, the_CLI_command that I had defined up in line 20. So it knows what the command is now. It's the show MAC address-table. And finally, it needs to know what the blob is so that it can go to work turning it into structured data. Well, what was the blob? Well, we had saved that in line 24, CLI_output_blob. So those are the things that parse_output needs to know so that it can interpret that data and parse it for us. Last command is lines 30 and 31 here. We're going to prettyprint, that's another library I brought in that I didn't have to install because it's core to Python, but I'm going to prettyprint CLI_output_structured, and I told prettyprint, hey, use an indent of 4. There's a whole bunch of different parameters that you can feed prettyprint. I was only worried in this case about indentation. That's our script. I just walked through it line by line, so what do we get out of it? Python 3, my script is basically just a text file. It's saved in something called machunter.py. Python 3 is the interpreter installed on my Mac that is going to take machunter.py as input, and let's see what happens. Should be logging into my switch that's running in my lab, gathering data, and there's our structured output that has been prettyprinted. What do I mean by structure? Well, remember the slide we talked about earlier in the episode. I've got a square bracket that indicates we have a list, and then within I've got list elements of dictionaries that go from brace to brace. So now I've got your destination address of that MAC and then all the characteristics of that MAC, and that makes sense. I should have MAC addresses and everything that goes along with it because we said show MAC address table. That's the information we were interested in. So I've got 5 little dictionaries that each make up 5 elements in this list, and the data is structured. It's all delimited now, right? I've got key value pairs, I've got list items, and now it's possible for me to reference any single item that is in this list if I wanted to. And that is something that we're going to work on in the next episode. We made a big stride today getting to the point of having some structured data, kind of a big deal. And we'll stop here and see you next week.